Hey guys, in this lesson, we're going to be talking about how do we find polynomial roots by using the zero product property. So the zero product property is the only thing that you guys will actually know that is new to you guys. We've already talked about finding roots in a prior lesson when you guys used the computers in the classroom. So to find polynomial roots, I remember you guys were finding solutions and roots of systems. So you guys have already done that before. But the only thing that's new is the zero product property. And it says that if you have the product, and remember product means multiplication, of any two numbers equal to zero, then the only way that that is possible is if one of those two numbers is zero. So I give you guys this illustration real quick. If you have two numbers that are multiplied together, for example, we have an x and we have a y, and they're multiplied together, and it's equal to zero, the only way that that's true is if either y is equal to zero or x is equal to zero. There's no other possible scenario, right? So y must be zero or x must be zero for that to be true. So this is called the zero product property. So the zero product property, sometimes we abbreviate it as ZPP, states that if two things are multiplied together and set equal to zero, then one must be zero. And by one, I mean one term, right? So if we have two terms, I said things there, I should probably be more precise. So if we have two terms that are multiplied together and set equal to zero, then one of those terms must be zero for this to be true. This is the zero product property. So just a quick recap on what we talked about when we looked at roots. We've already done this before. So when we talked about roots, another way to say roots is x-intercepts, where it touches the x-axis for each function. So there could be 1, 2, 3, 4, or no roots depending on your graph, right? Depending on your function. So when we're solving these polynomials, we're finding these roots using the zero product property. This is exactly what we're finding. So for example, the first graph has 3 roots. So 1, 2, 3 because it touches the x-axis 3 times. This second example has 2 roots or 2 x-intercepts because it touches the x-axis 2 times. And then the last one has no roots or no solutions, no x-intercepts because it does not touch the x-axis at all. So when we're solving polynomials, that's exactly what we're doing. We're finding the roots. We're finding the solutions where x is where it touches the x-axis or where y is equal to zero. So these are the steps. Step 1, not that many steps. First, you have to set the polynomial equal to zero. This is the most important thing. You must make sure that the polynomial is set equal to zero. Otherwise, it will not work. Step 2, if the polynomial is not factored, then you have to factor it completely. Step 3, set each factor term equal to zero. This is a zero product property, right? So we can apply it. Step 4 is solve for the variables. You may have multiple roots, aka multiple x-intercepts or solutions. So we're going to jump right into some examples here. Example number 1. Let's say you have two things that are multiplied together, set equal to zero, right? So it doesn't matter what these things are. It's just two terms multiplied together set equal to zero. So the zero product property says that for that to be true, then that means that either this is equal to zero for that to be true, or the second term is equal to zero for that to be true. So all we have to do to figure that out is solve each one of these, which are set equal to zero, and then we have our solutions or our roots. So you know how to do this already. You would set the wall here. You would add 5 on both sides, and you would get the answer for the first root as x is equal to 5. You would draw the wall for this, subtract 4 to both sides. You would get the answer as 2x equals negative 4, divide by 2 on both sides. So you get the second answer is negative 2. So there are two roots. My first root is x equals 5, and my second root is x equals negative 2. Those are the places where it touches the x-axis. Now, just because I'm a very great math student and I don't want to take anything for, fact, unless I check my work, if you go to desmos.com/calculator, you could actually type this stuff after you set it equal to zero, type this in to check your work. So watch, that's exactly what I did. So I typed in x minus 5, 2x plus 4 into Desmos, and then this is the graph that it gave me. So x minus 5, 2x plus 4. Notice that this is the graph. It's a parabola, so it's kind of like the letter U. We'll talk about how to graph this in the future. So my 2 points where it touches the x-axis is x equals -2 and x equals +5. And that is exactly what I got from my answers, right? X equals 5 and x equals -2, right? So there we go. So that was my first example. Second example, moving right along here. So we have find the roots or x-intercepts or solutions to the polynomial by using the zero product property. Again, zero product property, we have to make sure that it's set equal to 0. So in this case, it is. So we're good. Now, the next thing I need to know is I need to factor this out because I can't set each factor equal to 0 if it's not factored. So that's exactly what I'm going to do next. I'm going to do a big X, right? So try to factor this trinomial. We multiply a times c and put it on top, which in this case is 15. We're going to put b on the bottom, which in this case is 8. So you know how to do this already because we did it a bunch of times. Find two numbers and multiply to the top, but add to the bottom. In this case, 5 times 3 would work because 5 times 3 is 15, but 5 plus 3 is 8. So we're going to skip to the factors here. The number in front of the x squared is just going to be a 1. So I'm going to skip right into the two factors as x, 1x and 1x, or x and x. This will be a +5 for my first factor, and this will be a +3 for my second factor. So my two factors are x plus 5 multiplied by x plus 3. That would give me this polynomial factored out. Now, if I want to solve it, I want to use the zero product property, meaning that if for this to be true, that means that x plus 5 has to be equal to 0. And also for this to be true, then x plus 3 has to be equal to 0. So when either one of those cases arise, then that means that this is actually true. So we solve the first equation. Again, this is like, what was it, like 8th grade or something, when you should be able to solve something like this. So my first answer, sorry, that should be a negative. My first answer is x equals -5. That'll be one of my roots. My second answer is x is equal to -3. This is another one of my roots. So my two roots are x is -5, x is -3. Check your work. So again, I already went ahead and did this in decimals. X squared plus 8x plus 15. When I put that into decimals, x squared plus 8x plus 15. My two roots or my two x-intercepts happen to be here and here at -3 and -5. And that's exactly what we got, right? So my two answers were x equals -3 and x equals -5. All right, -5, -3. So 3 more examples. Example number 3. Find the roots or x-intercepts or solutions of the following polynomial and then verify your answer using decimals. So we have x squared minus 7x equals 0. Now, before I do anything else, I know here that I can actually take out a greatest common factor for this polynomial because they both have x's in common, right? So I can take out an x from both of those terms. If I do that, I'm left with x minus 7 on the inside, and now I can set that equal to 0. Well, if I apply the zero product property here again, that is the exact same thing as what we did earlier, right? So that means that if we have two terms that are multiplied together set equal to 0, or it could be more than two terms, then that means that either one of them is equal to 0, so I found one of my answers, or the other is equal to 0. So we're going to do that right there. And if you solve each one of these, that should give you the solutions or the roots. So when we add 7 to both sides, we get the answer is x equals 7 for one of my roots, and the other root is x equals 0. So again, get a problem. First, set it equal to 0. Second, factor it out. And then third, solve each component of each factor after you set each one equal to 0. So my two answers should be 0 and 7. I check my work. This is what it looks like when I graph it, x squared minus 7x. And my two solutions or my two factors are x equals 0 and x equals 7, just like I expected. So again, if you want to go ahead and check your work once you finish this, you can always go ahead and do that using decimals. All right, so last two examples. Example number 4. So find the roots of the polynomial by using the zero product property. Check your work using decimals. So the first thing that I see here is that if I want to use a zero product property, I need to make sure that this equation is set equal to 0. And in this case, it is not. So that is a big problem because we can't do anything else unless it's set equal to 0. So first thing I need to do is do exactly that. I'm going to add 14x squared to both sides, plus 14x squared plus 14x squared. And the reason why I'm doing that is because I want to set the right side equal to 0. If I do that, then this right side, positive 14, negative 14x squared, cancel out, and I'm just left with 0, which is what I want. On the left-hand side, I get 30x to the power of 3. And then there was that positive 14x squared that I moved over, and then the negative 4x. Notice that these are not like terms, so I did not combine anything. I'm just moving stuff around. Okay, now that I have this, the rest is the same. So have to factor this out completely and then set each component set equal to 0. So before I move on, make sure you always check to see if there's a greatest common factor shared between all of the terms. In this case, that answer is yes, right? There is a greatest common factor shared between all the terms. That greatest common factor, that GCF, is actually 2x. So I can divide all of them by 2, and they also all of them share an x. So I could actually take a 2x on the outside. Once I do that, I got to figure out what's left on the inside of that. And the inside of that would be 15x to the power of 2 plus 7x minus 2. So we're almost done here. You just have to stop and think, can I break this up a little bit more? You could actually break this up a little bit more, right? This is a trinomial squared. So most likely you can do the big X to try to factor this. So I'm going to go ahead and try to do that on the side. So forget about this for a minute. I'm going to try to factor this out. So when we do the X, on top, I'm going to have the 15 times the negative 2, which is the negative 30. On the bottom, I'm going to have a positive 7. So I want two numbers to multiply to negative 30, but add to positive 7. So 5 times 6 would not work because that would be 11 or 1. The only possible combination here is 10 times 3. So 10 times 3 is 30, but if I want a negative 30, I need this to be a negative 3, and then 10 minus 3 would give me 7. So this actually works out for my combination that I need. I'm going to skip to the two factors. So I'm going to, don't forget I have to include the a, right? So my two factors are going to be ax and then ax. And then the two answers that I got were positive 10 and negative 3. And then don't forget you also had that 2x in the front. But we'll include that in a little bit. So figure out what you can divide both of them by. These are actually divisible, both of them by different numbers. The first one I can actually divide both of these numbers by the number 5. And the second one I can divide both of these numbers by the number 3. So when I do that, I get my actual factors, which are 3x plus 2 multiplied by 5x minus 1. So these are my factors, and this came basically out of this that I underlined in blue. So this is what it simplified out to. So now that I factor this out in blue, don't forget that I still have that 2x in the front. So there are actually 3 factors for this, which means that when I do the zero product property, I'm not only going to do it for 2 terms, I'm going to do it for 3 terms. So I have the 2x, 3x plus 2, and 5x minus 1. So when I do the zero product property, I have to set each one of these equal to 0 and solve. So the first one would be 2x equal to 0. The second one would be 3x plus 2 equals 0. And the last one would be 5x minus 1 set equal to 0 by using the zero product property. Then when each one of these is equal to 0, then it will be a true statement or a true equation. First answer, that one's easy, x equals 0. Second answer, when we draw the wall, subtract 2 on both sides, and then divide by 3. Then we get second answer is negative 2 over 3. My final answer, same thing, draw the wall, add 1 to both sides. I get 5x is equal to 1, divide by 5, divide by 5. I get x is equal to 1/5. All right, so these are my 3 roots. These are my 3 X-intercepts, if you will. But be careful because for whatever reason, Desmos only does decimals. So negative 2 over 3. Another way of saying negative 2 over 3 is actually saying x is equal to negative 0.667, right? So that's the same answer there. Another way of saying 1 over 5, that is saying x is equal to 0.2 because 1 over 5 as a decimal is 0.2. So when we plugged it into Desmos and I graph it, then I can see that my original problem was this, right? This nonsense, but I'm not going to put the beginning of it. I'm actually going to put this part that I set equal to 0. So this is the part that I'm going to put into Desmos. to check my work because I got to put the part that is set equal to 0. When I type that into Desmos, 30x squared plus 14x squared minus 4x, this is the graph that I get. So it's kind of like an S. It goes up, it goes down, and then it goes back up. So it curves a lot. My X-intercepts are 3 of them. No surprise to you, right? And then those 3 X-intercepts happen to be at negative 0.667. The other one is at 0, and the last one is at 0.2. And those are the exact answers that we got. The 3 polynomial roots, or the 3 X-intercepts, are exactly that: 0, negative 0.667, and then x equals 0.2. All right. So that's basically it. I'm going to do one last one for comfort, so you guys are comfortable with it. Same exact deal, though. Solve it by using the zero product property, so which means you have to set it equal to 0. So example number 5, if I want to set this equal to 0, I got to move the 40w squared and the 80w to the other side. So that's exactly what I will do. I'm going to subtract 40w squared and then add 80w to the other side. Sorry, that should be an 80. So when I do that, I have to do it to both sides, 40w squared plus 80w. On the right side, which is what I want, everything cancels out, and I'm left with a 0. On the left side, I'm going to be left with 5w to the power of 3. I'm putting that first because it's the highest power, and then minus 40w squared, and then plus 8w. The rest is the same. Now that I have it set equal to 0, now I can use the zero product property, meaning that I have to factor, and then it set each of the factors equal to 0. So let's do that. Is there anything that I can take off of all 3 terms before I even do anything else? Is there a greatest common factor? So the answer for that is yes, right? So GCF, there is a GCF. The greatest common factor for this is actually 5w. I could actually take a 5w out of all 3 terms. When I do that, I am left with the trinomial as w to the power of 2 minus 8w, and then plus 16. And then, I just see my mistake here. My fault. So there was a mistake. That should be plus 80w here and here. And I messed up and I erased it, and then I fixed it, and then I messed it up again. So that should be an 80. I'm sorry about that. So that would multiply to 5w times 16 would give me 80w. Good thing I caught the mistake. Okay, so now that we're here, we have to check again. Is there a possible way for me to be able to break this down? And the answer for this, I think, is yes, because it's a trinomial squared. So I can try to use the x on this. So when I factor this out, 1 or a times c would go on top. 1 times 16 would be 16. B would go on the bottom, which is negative 8. So I want 2 numbers that multiply to the top but add to the bottom. The 2 possible combinations for that would be 4 times 4. Sorry, I was covering my notebook with my elbow. So negative 4 times negative 4 would add positive 16, and then negative 4 plus negative 4 would be negative 8. Okay, when I do that, I get 5w, which was still in the front from the greatest common factor. I'm going to break this down as w minus 4 from my first factor, and then w minus 4 from my second factor. And then the last thing I need to do is, after I set it equal to 0, solve each one of the components, and then I would get my roots. So the first answer for that, when I said 5w equals 0, then my answer for that will be w equals 0. Done. That's an easy problem to solve. My second one is w minus 4 equals 0. I have to solve that. I get w is equal to positive 4. Second one, done. My third one is exactly the same as the second one, right? W minus 4 is equal to 0, so that means that w is also equal to 4. So lo and behold, we actually have 2 roots, right? So when I'm saying 2 roots, because it's only 2 different numbers, right? These are both the same. So w equals 4, w equals 4, the same thing. So my 2 roots are w equals 0, and my second root is w equals 4. Okay, when I check my answer with Desmos, so I graph the original polynomial once I set it equal to 0. So this is the polynomial that I'm going to basically put on Desmos, because that's the one after I set it equal to 0, not before. So 5w to the power of 3 minus 40w squared plus 80w. So 5x to the power of 3 minus 40x squared plus 80x this is what I get. So it's another one of those S-looking curves. So it goes up and then down and then up again. So that's exactly what I get. I look at my roots. There are actually only two of them because the tip of that, the bottom of that, is where it touches the x-axis. So there are two roots. One of them is at x equals 0. The other one is at x equals 4. And that's exactly what I got with my answers. X equals 0 or w equals 0 and then w equals 4. I changed the w's to x's for decimals because decimal doesn't like other variables besides x. So that's essentially it. All right. So I hope you guys have a good one. That's it for today. See you on the next one.